Scalars and Vectors. Lesson 2. Hello, and welcome back to our linear algebra course. In the previous lesson, we learned what linear algebra is, why it is important, and how it forms the mathematical foundation of modern technologies such as artificial intelligence, data science, robotics, and computer graphics. Today, we will begin with the first and most fundamental concepts of linear algebra, scalars and vectors. Understanding these two concepts is essential because almost every topic in linear algebra is built upon them. Let's begin with a simple question. Imagine you are driving a car. If someone asks, "How fast are you driving?" you might answer, 60 kilometers per hour. This tells us only the magnitude, or size, of your speed. Now imagine someone asks, "In which direction are you driving?" You might answer, "North." When we combine both pieces of information, the speed and the direction, we get a complete description of the motion. This simple example introduces the difference between scalars and vectors. What is a scalar? A scalar is a quantity that has magnitude only. It tells us how much, but it does not tell us in which direction. Scalars are represented by a single numerical value. Examples of scalar quantities include temperature, mass, time, distance, energy, speed. For example, if today's temperature is 30 degrees Celsius, the number 30 tells us the temperature. No direction is involved. If a book has a mass of 2 kilograms, only the amount matters. If a journey takes 3 hours, time has no direction. These are all examples of scalar quantities. What is a vector? A vector is a quantity that has both magnitude and direction. Unlike a scalar, a vector answers two questions. How much? And in which direction? Vectors are usually represented by arrows. The length of the arrow represents the magnitude. The direction of the arrow shows where the vector points. For example, imagine a person walks 5 meters east. The magnitude is 5 meters. The direction is east. Together, they form a vector. Another example is velocity. Suppose a car moves at 80 kilometers per hour toward the north. The speed alone is a scalar. But when we include the direction, it becomes velocity, which is a vector quantity. Other examples of vectors include displacement, velocity, acceleration, force, momentum. All of these require both magnitude and direction. Scalar versus vector. Now let's compare them. A scalar has only magnitude. A vector has both magnitude and direction. A scalar can be represented by a single number. A vector is usually represented by an arrow or an ordered list of numbers. Scalars describe quantities. Vectors describe movement, direction, and position. Representing vectors. In mathematics, vectors are often written using column notation. For example, two-dimensional vector. This means the vector moves 3 units along the x-axis and 4 units along the y-axis. Another common notation is v equals 3, 4. Both represent exactly the same vector. In 3 dimensions, a vector may be written as 2, 5, 1. Here the 3 numbers represent movement along the x, y, and z axes. Why are vectors important? Vectors help us describe the world mathematically. Engineers use vectors to analyze forces acting on buildings. Pilots use vectors to determine flight direction. Robots use vectors to move accurately. Game developers use vectors to animate characters. Scientists use vectors to study motion and physics. Artificial intelligence represents data using vectors before making predictions. Without vectors, many modern technologies would not exist. Summary. Let's quickly review today's lesson. A scalar has magnitude only. Examples include mass, temperature, time, distance, and speed. A vector has both magnitude and direction. Examples include displacement, velocity, force, and acceleration. Scalars describe how much. Vectors describe how much and which direction. These two concepts form the foundation of linear algebra. In the next lesson, we will learn how to add and subtract vectors, one of the first mathematical operations you'll perform in linear algebra. Thank you for watching. If you enjoyed this lesson, consider subscribing to the Hidden World of Numbers, where we explore mathematics with clear explanations and real-world applications. I'll see you in the next lesson.